In the previous video, we reviewed setting up an environment to access Oracle databases using R. In this video, we will review objects in R, objects in the database, moving objects between those instances, adding a dataset through R, exploring data, and finally creating a classification prediction model. When a user connects to R, they automatically have access to their default schema. This is the case since the all equals true was specified in the connection string from the previous video. The or.sync command generates a data frame for each table in the schema using a proxy. Within R, a data frame is a list of equal length vectors used for storing tables. The Oracle R packages refer to these as ore.frameObjects. Oracle documentation suggests not syncing all tables as this will create unnecessary overhead. Instead, you should only sync tables that need to be accessed via R. To view all sync tables, or in other words, all ore.frameObjects, the ore.ls function can be used. This command returns the state table, which is a table that was previously set up in the database. By running the class command against the state object, we can verify the type of object it is. In this case, it's an ore.frameObject. To move objects between our local memory and the database instance, you can use the push and pull commands. First, we'll pull the state table into an R data frame called local data state. This data frame now exists in local memory. We can confirm the class of the local state data frame by checking its class. The iris data frame is a data frame built into R that is useful for demonstrations. First, we'll inspect the data frame using the head function. Then we can push this data frame to the database using the ore.push command. The ore.push command creates a temporary table instance in the database that is lost when the session disconnects. To create a persistent durable table, the ore.create command can be called. We'll then sync and list the tables. We can see the iris table now exists along with the state table. Switching over to SQL Developer, we can confirm this table now exists. Back in the R console, we'll begin a classification mining script by reading in two census datasets from the UCI machine learning repository called the adult dataset. The task assigned to this dataset is predicting whether the income class is greater than or less than $50,000 based on other census information. The training and testing datasets are accessed directly from the UCI server archive within a read.csv call. We can quickly inspect a few rows from the data to ensure it looks correct. After inspecting the testing dataset, the first row is removed from the testing data as it does not appear to be useful. We can confirm this row has been removed. Next, we'll add a column to each of the datasets that will help uniquely identify each value and provide a means of indexing. Vector data in R relies on a strict order of elements that can be indexed. This improves the efficiency of processing done in R. On the contrary, relational data queries are not ordered unless specifically requested, and this becomes an issue when using ore.frameObjects. To overcome this issue, the row.names command can be used to assign a row name and permit ordering. The columns are reordered for readability. Next, we'll update the column names in each dataset using information from the UCI dataset archive. For the purposes of this classification task, we'll limit the number of columns for simplicity. The keepCalls vector contains the columns we wish to keep. In this case, ID, age, education number, marital status, occupation, relationship, hours per week, and class. Both data sets are then overwritten with just those columns. We'll then push the R data frames to the Oracle database using the push commands. This allows us to leverage the processing power using Oracle as the back-end database. Note the use of the OF suffix naming convention. This will help us differentiate our Oracle R data frame objects from the other R data frames we created. Earlier we mentioned the importance of unique keys in the dataset. By running the row.names command, we are setting these columns and allowing indexing to occur. Before we begin building our classification model, we'll take a quick look at two powerful data exploration functions. First, the summary function gives us a nice overview of our data showing the distribution. Note here that I am now calling on the new data frame that exists in the Oracle database. Next, we can use the aggregate function to calculate aggregates based on a specific grouping. For this demonstration, I am calculating the mean age based on each type of marital status. Data mining tasks, such as classification, use algorithms to find interesting patterns. For the next demonstration, we'll be demonstrating a classification model using the naive Bayes classifier. The naive Bayes classifier is based on Bayes' theorem of conditional probabilities with independent values. The R language has many different packages that can be used for such a task. For the purpose of this demonstration, I will use the naive Bayes classification function built into the Oracle package. This is the ore.odmnv package. There are various other R packages available on CRAN that can accomplish the same. The Oracle ODMNB function is adapted from Oracle's data mining package, which is part of the advanced analytics feature of Oracle Database Enterprise. The first step is to create a naive Bayes model using the training dataset. Next, we'll make class predictions using the generated model and running this against the testing dataset. From the prediction results, a confusion matrix table is generated which shows which classes were predicted accurately. From the confusion matrix table, we can see that 10,367 records were accurately predicted from the less than or equal to 50,000 class. This represents 83% accuracy. 2,898 records were accurately predicted for the greater than 50,000 class. This represents 75% accuracy. Through this demonstration, the scalability and reproducibility of the R language becomes quite clear. We've downloaded datasets, transformed and summarized data, and generated a prediction model in just a few simple steps.